Hello everyone, welcome back to T-Learn, and today we'll be going through the subtopic 1.1 Computational Thinking in the T-level for Digital Software Development in Core Paper 1. So let's get started. So here are our learning objectives for today. 1. Computational thinking in depth. 2. Decomposing problems. 3. Pattern recognition. 4. Abstraction. And 5. Interrelationship between computational thinking components. So what is computational thinking? Well, computational thinking is not just about how computers think. It's actually about how we can represent a problem in a logical and structured way so that solving problems becomes much easier. And computational thinking focuses on four main ideas, four main components: decomposition, pattern recognition, abstraction, and algorithmic design. So let's go into them. So yes, we got computational thinking, but what is actually the purpose of computational thinking? Well, there are three main purposes. 1. It helps us approach complex problems systematically, enables solutions to be automated or implemented in software, and also improves efficiency and accuracy in problem solving. When to actually use computational thinking? Well, there are some main ones: designing software digital systems, analyzing large data sets, problem solving in maths, science, engineering and technology, automating repetitive tasks, and breaking down complex real-world problems into simpler steps or even simpler problems. So here we got a table showing the advantages and disadvantages of computational thinking. First, let's explore the advantages. Well, there are three main ones. Computational thinking helps us break down complex problems into more manageable parts. It promotes logical, structured thinking and also enables automation and efficiency in software solutions. The disadvantages are that it can be time-consuming for simple problems, it requires training to apply effectively, and it may oversimplify real-world problems. Now let's delve in a little bit more. Let's look at the advantages and disadvantages of computational thinking components, so decomposition, pattern recognition, abstraction, algorithmic design. Some advantages include simplifying complex problems or even helping predict outcomes. And some disadvantages include the time-consuming side of it and it leading to incorrect assumptions. Feel free to pause the video now if you would like to view the table more or if you'd like to take notes. So now let's move on to decomposition. It's the very first step when solving most problems and will require some sort of breaking down, which is what is known as decomposition. This essentially breaks down a complex problem into smaller, more manageable tasks, which makes it easier for a person to understand when given one of the tasks to do. There are four main steps of decomposition. 1. Identify and describe problems and processes. 2. Break into distinct tasks. 3. Describe the task and the subtask. And 4. Communicate key features to other members of the group. So, there are methods of representing decomposition. 1. Block diagrams. 2. Information flow diagrams. 3. Flowcharts, which we'll learn about in 1.2. Codes and written descriptions. Let's now move on to pattern recognition. When solving problems, it helps us spot similarities or repeated patterns in data or tasks. This process is called pattern recognition. By identifying patterns, you can solve new problems faster by applying solutions that worked before, such as making a new function or a procedure in Python in programming. So here are the steps of pattern recognition. 1. Identify the problem. Decide what needs to be solved. 2. Look for patterns. Find similarities or repeated steps in the problem or related problems. 3. Group similar features. Organize similar parts or tasks together. And finally, 4. Apply the pattern. Use the recognized pattern to solve the problem efficiently, such as making a function or just simply using the same code again. So now lastly, let's move on to the interrelationship between computational thinking components. So, to begin with, decomposition identifies parts of the problem, pattern recognition finds trends across the parts, abstraction filters irrelevant details of those parts, and algorithmic design defines step-by-step solutions so that the problem can actually be solved. And that was it for 1.1 Computational Thinking in the Digital T-Level Software Development course. Thank you for choosing T-Learn, and I hope you visit our website soon.